Hello, we are on Algebra 1, Lesson 2.3. If you're following along in the online book, this is Module 2, Page 3. It's going to be a short lesson today. We're going over literal equations. And what literal equations are, it's very simple. It's equations that will have more than one variable in them. So something that you might know as a formula. Okay, so here I have one written out for us that says P equals 2L plus 2W. This is, if you recognize it, the formula for the perimeter of a rectangle where L would mean length and W would mean width. Here's another one, A equals 1/2 BH. If you recognize this one, it is the area of a triangle and 1/2 base times height, okay? Distance equals rate times time, okay? So these are all examples of literal equations. Now, you are used to being given some information and filling it in and finding the answer. So if you're looking for the perimeter of a rectangle, you're usually given the length and the width, and then you have to find the perimeter. But sometimes you can be asked with literal equations to solve for one of the variables. Okay, so when you solve for a literal equation, asked to solve for one of the variables, you're simply going to rearrange the formula to get that particular variable by itself. And the answer is not going to be what you're used to. It's not going to be just a simple number. It's usually just a different form of the same equation. Like if you take silly putty and you have it pushed all into a ball, and then you take that same silly putty and you stretch it out. It's still the same thing. It's just in a different form. So here we have solve the equation for H. And this is our area of a triangle. So A equals 1/2 base times height, right? So what are we going to do with this? Well, it says we have to solve for H. So that means we want to get H to be by itself. So we need to essentially, just like what we do with any other equation that we're solving, usually for X or something to that effect, we undo what's being done to the variable. So we're going to do that here as well. We're going to undo what's being done to H. Well, what's happening to H right now? Well, the first thing I see is that it's being multiplied by B. So in order to undo this multiplication of B into H, we have to divide by B. But remember, we have to do it to both sides. So when I do that, this is going to cancel out. So I'm going to be left with A over B equals 1/2 H. And if you remember, when you have a fraction, this is really a division. We're multiplying by 1 and dividing by 2. So if we're dividing by 2, that's the same thing as multiplying both sides by 2. Well, when I multiply by a fraction, I should also turn this into a fraction, right? So this would be 2 over 1 times A over B. And what does that give me? That gives me 2A over B. All right, so here I have 2A over B equals H. Now you can rewrite this with the H in the front because we're used to seeing the lone variable on the left-hand side and the equation on the right-hand side. So H equals 2A over B. And that's how you solve for H. So we have some literal equations practice for you. I told you it was a quick lesson. So here we forgot number 1 there. In number 1, you're going to solve for B. So A equals B times H, solve for B. Here, you're going to solve for R. Here, you're going to solve for W. So I want you to go ahead and pause the video and see if you can get these done yourself. Then unpause when you're ready to go over the answers. All right, so number 1, we're going to take this equation, A equals B times H, and we're going to solve for B. I'm just going to write it over here, so I have a little bit more room. I see that what I want to solve for right here is B, and what's happening to B right now is it's being multiplied by H. So in order to undo that, I'm going to divide by H on both sides. Okay, that's going to cancel out, leaving me with only b. So I'm going to write this equation with the variable that I solved for first. B equals, what's left on this side? I've got a over h, and that's my final answer. Okay, with number 2, we're going to solve this equation, d equals rt. We're looking for distance, rate, and time for r. So if we're given the distance and we're given the time, but we don't know what our rate is, this would be a way to solve it. So we're solving for r. Matter of fact, I want to write this in a different color, just so I can remember that I'm solving for r. Sometimes that's helpful for me. Okay, so I want to get r by itself. So what's happening to r is it's being multiplied by t. Again, I'm just going to divide by t. Well, that one was easy. R equals d divided by t, because my t's canceled out over there. All right, and last one here, I've got P equals 2L plus 2W. This is to find the perimeter of a rectangle. And we're asked to solve for W. So I'm actually going to, again, this one's a little more complex, so it makes more sense for me to make sure that I have that in a different color to help me make sure I'm doing this. Now, when you're solving equations, you do the opposite of PEMDAS. So we're going to go up the PEMDAS line, right? So we start with addition and subtraction, which is at the bottom. That's what we need to undo first. So the 2W is stuck together for right now, and we're going to undo this thing that's being added to it. Well, what's being added to 2W? 2L is being added. So we're going to subtract 2L from both sides, okay? And that's going to cancel out on this side. So on this side, I'm going to have P minus 2L. Usually with L's, we're going to write them in cursive in algebra, equals 2W, okay? Let me write that W again in a different color just to help me a little bit. All right, so what's happening to the W now? It's being multiplied by 2. So I have to divide by 2. But when you divide by 2 and or by any number, and there's more than one term on the other side, you need to make sure to divide by 2 for both terms. Not just one term, but both terms, okay? Every time when you divide each, when you divide, undo multiplication through division, you have to divide each term that is in the entire equation by what you're dividing. Same with if you were to multiply things, you would multiply every term by what you're multiplying. Division and multiplication are definitely treated different than addition and subtraction. All right, so here we have P over 2. So that's just a fraction. You could rewrite this. I'm going to rewrite this as 1/2 P, because what is the coefficient here in front of B? It's a 1. And I like the way that looks better. So that's how I'm going to write it. 1/2 P. Okay, so I did that one. Minus 2 over 2. Well, those can cancel out and leave me with just an L. So 1/2 P minus L equals, okay, those had canceled out. And I'm left with just my W. I like having the W first. So I'm going to write it like this and find my eraser and erase that. So I'm left with W equals 1/2 P minus L. I solved for W. And that is how that practice. Now I have one more equation for you, or example for you. What I want you to do is go ahead. This is a real world example. And there's going to be several parts to this, but we're going to start here with writing an equation to represent the cost of something. It says the cost of the field trip tickets. So let's look at what we have here. We've got Mr. Jackson. He wants to take his biology students on a field trip to Ziggy Zany Zoo. Student tickets cost $5 and adult tickets cost $8. So 5S would represent the cost of the student tickets. 8A would represent the cost of the adult tickets, because no matter if you had 2 adults, you do 2 times 8. and that's how much the adult tickets would cost. If you had 10 students, it'd be 10 times 5. Okay, so those are separate little possible terms we might use, but I just wanted to go ahead and write that down so it helps me later on. So now we're going to write an equation to represent the total cost, and it wants us to use the letter C to represent the total cost. So total cost is going to be how much it costs for the student tickets plus how much it costs for the adult tickets. So 5S plus 8A. And that is the equation to represent the total cost of the field trips. Now, if 30 students and 4 adults attend the field trip, what will the cost for the tickets be? Well, this is going to get into that word we learned or went over at the beginning about substitution. So we have 30 students. That's going to plug into this S right here. We're going to plug a 30 into that, okay? And then we have how many adults? 4 adults. So that's going to plug into this A right here. And that's going to be how we determine our total cost. So we're going to have C equals 5. Okay, then I've got to plug in times 30, right? And then I continue on plus 8. And now I've got to plug in how many adult tickets there are times 4. Now, am I solving for a variable or am I just going to complete the equation? Well, there's no variables in here. So I'm just going to complete this math, all these operations the way I normally do. So I'm going to, when I think of PEMDAS, I'm going to work downwards in the proper traditional order. You only work upwards or the opposite order when you're undoing operations in math. So there's no parentheses, no exponents. So I need to start with my multiplication and division first. So I've got some multiplication here as well as here. I start on the left and move to the right. So C equals 5 times 30. Well, 5 times 3 is 15. Throw a 0 on the end. Plus 8 times 4. Well, maybe I don't know my 4 times tables, but I know how to double stuff. I know what times 2 is. 8 times 2 is 16, and 4 is twice that. So 16 times 16 is 32. So 150 plus 32. Now I'm going to be on my addition and subtraction step. I'm going to add right here. So the cost is 150 plus 32 is 1. 5 plus 3 is 8. 0 and 2 is 2. $182. It's expensive to go to that zoo. Wow. All right. Here's another question for us. I'm going to erase this so we can read it. Ms. Jackson is given a budget of $300. He must take 6 adult chaperones. How many students would he be able to take if he has to take 6 adult chaperones? Okay, well, it's got to be under $300. This is going to get us into our next lesson with some inequalities. So this is a little bit of a preview for us. We know our cost cannot exceed 300. So our cost has to be less than or equal to $300. And he must take 6 adult chaperones. So I'm going to start with my adult multiplication term that I have here. 8 times 6. Okay. How many students can attend the field trip? Plus, now I'm going to plug in my student term here. 5 times S. So we want to know how many students can attend this field trip. So we have to look at what's going to be less than or equal to $300, which is his budget. So let's start by combining our like terms or doing any operations that we're able to just go ahead and complete before we undo stuff. 8 times 6. Okay, well, 8 times 5 is 40. I know that one. So 8 times 6 has got to be 48 plus 5S. And that stays just the same. We're not going to do anything with that. We'll get into the rules involving inequalities in the next lesson. But we're not going to have to observe any of those rules in this problem that we're working on right now. So we're just going to continue as usual. The next thing you need to do is we're trying to solve for a variable here, s. So we're going to be moving up our PEMDAS, not down. So we have to undo any addition or subtraction first. So we're going to undo this 48 that's being combined with the 5s. We look at the symbol in front of it to see if it's positive or negative. There's no symbol there, so that means it's positive. So we need to subtract 48 from both sides. Okay, well, 300 minus 50 is 250, but I didn't take away all 50. I only took away 48, which is 2 more. So that's going to be 252. 252 is greater than or equal to, this canceled out, 5s. Okay, well, to undo what's being done to the s, I have to undo the multiplication because it's being multiplied by 5. So I want to divide by 5 on both sides. All right, so divide by 5, 252 divided by 5. Pull out my handy dandy telephone calculator here. 252 divided by 5 is 50.4. Okay, so in order to stay on budget, 50.4, we have got to take S has got to be less than or equal to 50.4 students. So, how do I take a 0.4 student? I don't think that I can just take an arm and a leg and leave the rest of the student at school and get a discounted price. I think that the result of that might end up with incarceration instead. Instead of looking at the elephants behind bars, my students would be coming to visit Mr. Jackson or me behind bars instead. So I think that I'm not going to choose that option. And if I chose 51 students, I would be over budget because my students have to be less than or equal to 50.4. So the total number of students I am able to take on this trip is only going to be 50 because 51 just won't work. 50, I can't take 51. That would put me over budget. So this is a word question. Let's come up with a word answer. And the answer that you would write down is Mr. Jackson can take up to 50 students on his trip. All right. I hope that y'all understood literal equations, and we'll see you for the next lesson.